Alright, another day, another video. Form 4, Chapter 6, Linear Law.
So in linear law, we're going to be looking into two things, which is linear law and non-linear relations. We'll be looking into this formula, big Y equals M times big X plus C. And then we're going to be looking into the applications of linear law. So that's usually just how do we answer those graph questions. Alright, so first things first, we're going to look into linear law and the non-linear relations. So if we look at both of these graphs, they're actually plotting two of the same equations, which is y equals x squared plus 1. Now, the only difference over here is the fact that our axes are different. Sure, we can say that our y-axis is still y, but for our x-axis, if you look at the first graph, we're actually using the value x, whereas our second graph is using the value x squared. So this is how linear law works. It's basically changing the axis of either both or just one of the axes to make the curved line, the curved graph, into a straight line graph. So basically, the way we do this is by using the formula big Y equals to M times big X plus C. So in this case, you already see that my axis is x squared. So I have to find a way to make it to where my big X will be x squared. So usually I would do something like this. When I answer a question, I would actually just draw arrows to show where I'm bringing it down to. Now, we don't really know where our M is right now. So the easiest way I usually do it is to interpret this as y equals bracket 1 x squared plus 1, so that I know that 1 is the gradient. I know you don't necessarily have to write this down, but having that 1 at the front just makes my working look cleaner. So if I bring it down to my big Y, big X plus C, we can already see that this will be our new equation, where for the straight line graph, our gradient equals to 1, our y-intercept equals to 1, but our x-axis is represented as x squared, but our y-axis is still represented as y. Okay, so that's how you would extract information while doing these questions. Now let's look at the second example. This is a bit tougher. So let's say they've given you y equals to pq to the power of x. So this time it's more unknowns rather than a specific number. So they ask you to create a straight line graph out of this most probably curved equation, right? So if you see an indices, you gotta straight away think about the fact that you're gonna have to use logarithms, alright? You're gonna have to use all the log 10, everything that we learned in chapter 4. So what I will usually do first is to log the whole equation. So it will become log 10y equals log 10 pq to the power of x. So then just recall all of our laws again. So this would be the same thing as log 10 p plus log 10 q to the power of x, which that means we can actually bring forward. So I can straight away bring forward my x log 10q plus log 10p. I'm arranging it immediately because I know that log 10p, which is not a coefficient of x, is straight away going to be the y-intercept, plus c. And then now I'm just going to rearrange it so that it will look pretty when I drag it down to my big Y, big X formula. So it becomes a log 10q, then my x, and plus log 10p. So immediately, if I write y equals m big X plus c, my arrows down, we can immediately see that c will equal to 10, m will equal to log 10q, and we already know that the y-axis and x-axis will be represented by log 10y and x respectively. So the reason why I do my questions like this is because usually questions will be asking about what will the y-intercept be, what will the gradient be. So this is an easier way to find these points immediately. Alright, so now we're going to be looking into the applications of linear law. So when you're answering these linear law questions, usually they'll give you, let's say, x and y values, and then they ask you to draw a line of best fit. Okay, so first things first, what is a line of best fit? So I've drawn 3 examples here. So usually when you are plotting your graph, you're going to literally draw x's on the graph, right, as points for where your line is going to cross. Now then, basically, you won't necessarily get a graph where all the x's are actually on the literal line. Sometimes they might be a bit off, like some are up, some are down, but there will still be some that are on the line. But then there'll be cases where you might have drawn your line to where there are 2 values which are like off, you know, on the top side, and then there's like, and then it's still connected to 1. So basically, based on the 3 examples I've drawn here, the only ones that are lines of best fit is the first one, the second one, but not the third one. Alright, so let me explain this furthermore. Basically, the lines of best fit, they have to follow these 2 rules. It's either they pass through all the plotted dots or crosses, whatever you like to do, or they have equal dots or crosses, the ones that you plotted, above and below the line. So if you look at our second example over there, as you can see, the dots that are above and below the line are actually the same, which is one on the top here and then 1 on the bottom. So since they're equal, they are lines of best fit. But the moment that there are not equal dots or crosses above or below, like say the third one, right, 2 and 0, that immediately is counted as not a line of best fit. So basically, when you're doing lines of best fit, you have to make sure that your line is passing through as many of those dots or crosses, but at the same time, if they were to miss a dot or cross, the number of dots and crosses that are on the bottom and the top have to be the same. But there are special cases where you may leave 1 dot or cross above or below. Like say the ratio was like it was 1 at the top and 0 at the bottom, or 0 at the top and 1 at the bottom. This could be allowed if, let's say, the line was really near to the dot or cross. Like it was extremely close, like not even like this. It has to be like literally like over here, you know? It has to be that close. Then you can count that as a line of best fit still. Alright, now let's look at how we answer the linear law questions, especially the ones that include drawing graphs. So usually they will point out what axis that you will need to find. So like, let's say I got an equation like the y equals pqx we did just now. So from here we already know that, oh shoot, it has to be a log equation. That's why when we did the example just now, we knew that, okay, it was going to get log 10y equals to log 10q with the x plus log 10p. So basically, we already knew that our axis for this one had to be log 10y and x. So sometimes they might not point it out, but it's pretty obvious when you're doing the working actually. But a few things that you have to make sure you have in your working when you answer linear law questions is, 1, you have to have the table. Basically, make sure you write the table. You don't have to repeat the values of x and y they gave. Usually they will give you the x and y value, but what the table that you have to mention is like the new axis, which is like the log 10y or the xy. You have to find those values. Basically, to find these two, you have to take from the above. So basically, just log the value of like 5.8, for example. That's how you find the value of log 10y. And what else? Usually, you have to make y the subject when you use the formula y equals mx plus c, right? The big Y and the big X. You have to make sure that y is the subject. But there are like certain cases where we have log 10y over here, it will be log 10y as the subject. But that's only because we had to get x at the base over here. And then sometimes there will be questions that ask you to take the values from your graph. So basically, make sure that you check your graph values properly. All right, this is very, very important. Just check the graph values properly. All right, make sure you use a ruler when you're doing that. Make sure it's straight, always like that. And the most important one, they will usually ask you to find the gradient. All right, they ask you to find the gradient of your formula. And what usually workbooks do is they actually they basically use the values that are already on the graph. Like basically they draw a line from, let's say, a whole number and straight away to the graph and use that value. But what I like to use instead, which is easier, is to use one of the values over here in the table, which has to actually intercept the graph. So like let's say 3 was below, 4 intercepted, 5 was above, and 6 intercepted. So basically I only use the values that intercepted, which was in this case 4 and 6, because we already know that if they intercepted those values, they are the most accurate. So sticking to those most accurate values are much better. Alright, so lastly I'm going to cover some tips. Actually, most of the tips I've already said in both of my linear law and nonlinear relations, and also the application of linear law. I've already mentioned a lot, which is like how to determine the line of best fit, and like determining making sure that y is the subject. Make sure you check the values of your graph properly. Those are actually my tips. But I think one more that I could add on is when the question asks you like find the value of y when x equals something, or vice versa. So like value of x when y equals something. Alright, so the important thing to note here is that the equation that you've written, so let's take like the example we used just now, which was log 10y equals bracket log 10qx plus log 10p, right? Basically, we already know what the value of log 10p and log 10q would be, right? So when they've given you the value of x, you actually have to work your way backwards into finding the value of y. As in, once you sub in the value of x, lastly, you're for sure gonna have to make it to where it becomes like 10 to the power of something, right? Because it's log 10, and that's how you neutralize the log 10. So basically, just be careful with this, because working your way back to finding y, you just have to make sure that in this case, when you want to find y, you're not finding log 10y, you're finding y itself, okay? So just keep that in mind. You're not looking for big Y, all right? You're not looking for this. You're looking for this. Why did I cross that? I think another tip I could mention is probably like the question for number 1. Sometimes they will actually mention values. Like say for example, like the same equation just now, right? Our log 10y over here. So sometimes they will say that this straight line actually has values already, as in they already passed through a certain point. So when they pass through a certain point, all right, and we already know our x is actually log 10y and x, right? So you have to make sure that what you're writing is that it will become, let's say this is 1 and 2, right? And then this is like 3 and 4. So we already know that log 10y is, we have to make sure that we understand that the coordinate 1, 3 isn't xy, alright? It is not equal to this. It is in fact equal to x log 10y. This is a very important thing to keep in mind when you're answering questions, because there will be cases where you have to change the values, you have to change it back to the curve graph, and it is a huge mistake if you get this mixed up, alright? Just keep in mind y equals mx plus c is very, very different compared to big Y equals m big X plus c. I think that is all that we need to know for this chapter. I hope you guys enjoyed this.
Thanks for watching, guys. I'll see you next time. Ciao, Lu!